Welcome to our pre-AP notes over covalent and acid nomenclature. To know that it is a covalent compound, it's got to be with a nonmetal with other nonmetals, which means we are focusing on this portion of the periodic table. Two elements from over here, hydrogen is included as a nonmetal. When nonmetals share electrons, so they don't transfer, they share, there's lots of possibilities. For example, with nitrogen and oxygen, here's just a few of the possibilities that you could find for the way they combine. So unlike ionic, where there's a definite charge on each element and that charge was, there and you could crisscross and reduce, you can't do that here because of the many possibilities. So what we do is we give the name of the formula a way to indicate the number of each atom in the formula. So we're going to use prefixes. So you're going to want to be sure that you know the prefixes for the numbers. They have been given to you in many places. Mono, di, tri, penta, hepta, octa, nona, deca. Should be very similar to what you've learned in math class. Some other details. If we have one of the first element, so in CO, we have just one carbon, we will drop the prefix. So we're not going to say monocarbon monoxide, we're going to say carbon monoxide. Now please note in the second element, we do use the mono. Mono is there for oxide twice. All right? So it's only if it's on the very front that you would be writing mono that we drop it. Now also, just so you know, when we put mono with oxygen, we normally drop one of the two O's so that we can say monoxide, not monooxide or monoxide or something like that. It just sounds better to say monoxide. We do still end covalent compounds in the word "ide," so be sure you expect that. So let's look at some examples. I have one nitrogen, so that's nitrogen because I've dropped the mono. I have one oxygen, that's monoxide. I have two nitrogens, that's dinitrogen. I have three oxygens, that's trioxide. So the prefix is the number is the prefix. They match. There's no crisscrossing, there's no reducing, it's just the way it goes with prefixes, which actually makes it really nice and easy, but makes it very different than ionic. So 2 nitrogens is dinitrogen, 5 oxygens is pentaoxide. When writing the formulas, we again don't crisscross or anything, we just turn the prefixes back into the numbers. That's all we do, and we will never reduce covalent compounds. That's reserved for ionic compounds and acids. Speaking of acids, let's look at how we're going to name acids. Acids are special compounds. They do have ionic bonds, but when they dissolve in water, they break apart into hydrogen ion, H+, and that's what makes an acid an acid. So it does technically have to be dissolved in water to be an acid in the first place. We have two types of acids. We have acids that do not have oxygen in the formula. We call that a binary acid. And we do have acids that do have oxygen in the formula, and go figure, we call that an oxyacid. Big difference in the type of acid, small difference to the name. So be sure that you're keeping track of the difference in the name. For binary acids, that is those with no oxygen, we're going to use this form, hydroblankic acid. What goes in the blank depends on the root of what's stuck with your hydrogen. So if hydrogen is stuck with iodine, I would use iode in the blank, hydroiodic acid. If hydrogen is stuck with cyanide, I would put the root of cyanide, cyan, in the blank, hydrocyanic acid. Okay. Now you're like, wait a minute, this is 3 and we call it a binary acid. Yeah, that's true, but this works because it doesn't have oxygen in it. Here's the roots, and you've been given this in your helper packet as well, but be sure you're familiar with them. Bromine is brome, nitride is nit, and so on. Please note, With phosphorus and sulfur, we do have the UR and OR back in. Now, oxyacids have hydrogen, have oxygen, because they're oxyacid, so H to be acid, O to be oxyacid, and there will be another element, typically a nonmetal, but sometimes a metal, in the middle holding that all together. Very literally, like if we drew out the structure, it'd be in the center of the structure. This portion will be a polyatomic ion that I have asked you to memorize, so you should be able to recognize that as something. The problem with the polyatomic ions is we have 8s and we have ites. So the way we name our acids is going to have to reflect whether it was an 8 or an ite polyatomic ion. So what I want you to know is if the suffix on the ion was ite, the suffix we use in our acid name is us. Ite and us go together. If the suffix on the polyatomic ion was 8, the suffix on our acid is going to be ick. 8 and ick goes together. I have a little saying, I ate it and it was icky, and that reminds me that 8 and ick stick together, and then by default, ite and us must be together. So, here's my formula. I want to know what's the name. Well, obviously it's an acid if it starts with H. This part here, C2H3O2, you should recognize as acetate. Now, as a covalent compound, I would have asked you to write hydrogen acetate. To turn that into an acid, by dissolving it in water, the 8 becomes ick, and we add the word acid. So, acetic acid. Please note that we had a very similar form with binary acids, but they were hydro blank ick acid. Check out the similarities. Note the huge, important, major difference. I know it's a binary acid with hydro. Without hydro, when it's missing, then I know it's an oxyacid. Please be very, very, very careful about that. Hydro means no O. There should be no oxygen in the formula. No hydro, yes O. There better be oxygen in the formula. Okay. This over here you should recognize, the H tells us it's an acid. The NO2 you should recognize as nitrite, so it's hydrogen nitrite. If 8 and ick go together, then ite and us go together, so it's nitrous acid. And again, no hydro because it does contain that oxygen atom. If we know the name of the ion, we replace 8 with ick and us with ite. To go backwards, we just undo that. First, you want to determine if it's a binary acid or an oxyacid, and you'll know that by whether or not it has the prefix hydro in front. If there is hydro, there is no O. Hydro means no O, no oxygen. Without hydro in the front, but still acid on the end, you know it must be an oxyacid. Then you determine all acids start with H, so you determine what's going to go after the H. Is it going to be an element because the name started with hydro, or is it going to be a polyatomic ion without oxygen like cyanide? Or is it going to be a polyatomic ion because it did not start with hydro and it therefore must have oxygen in the end and something else holding it together? Once you figure out those two pieces, we know hydrogen's a positive. We will know what charge this is because I've asked you to memorize those. That's why you've memorized that list. And we're going to crisscross and reduce. And that's how we do our acids.